Now recording. It's nice how attendance is still great. Love it. All right. Sorry about the delay, folks. Not that it was my fault entirely.
I have a question. Where can we find the videos once they're posted? Just on your YouTube?
Just on my YouTube channel.
Is there a link on the My Canvas for it? Or should I just search your name?
Someone needs to send me an email to remind me. I keep forgetting to do that.
I'll send you an email right now.
Thank you. Yeah, so on the YouTube channel, I'm collecting up all of the videos into a playlist. And, you know, that's the easiest way to get all the videos. Okay. All right. So we're going to do some Visual Studio Pure C# today. Thought we could talk a bit about loops. Remind me, how far did we get with loops before? Did we do them at all? Did we do while loops?
Yes.
Okay. Perhaps we will start by recapping while loops. Loops are like for introductory programming, introductory level programmers. Loops are usually the first like real stumbling block in terms of the material. So, Visual Studio. So, on your lap computers, please open up Visual Studio. Create a new C# console project. Thank you. Skip. Dark theme. Very good. Also welcome.
Thank you.
Our numbers swell. So, create new project. C# console app. Next. Call it whatever you want. Whatever you want. There you go. Create. Bing, bang, boom. And here we have it. So let us review our friend the while loop. Remember that a loop produces repetition in segments of code. This repetition is decided by the same construct that decides between the branches on an if statement. So, if we have program execution entering a decision, and we have a true branch and a false branch, where this is, the condition, we execute A or B. This is our if statement structure. If we enter a condition, C, on true, execute some statement A. When that's finished, return to the top, and then on false, continue with the rest of the program. This is the loop structure. So, if I recall last time, I did some flowcharts for you folks, and you implemented them, and that was how we did things. Yeah? This time, let's work with word problem statements. So, I will do one with you guys to start off with. Let us compute the sum of all even numbers between 20 and 50. Does anybody have any idea how we might approach this problem? I suppose I just wrote this on the side of the board that like 3 people are sitting on versus like the rest of you. Deal with it. I'm not writing it again. Too short a class. So, yes?
I would start with an integer that is equal to 20, and then make a while loop that while that integer is below or equal to 50, it continues to run and adds 2 to it each time it runs through.
So let's take a look what that looks like in code. So, to declare an integer, let's say integer x is equal to, oh my goodness, the stupid autocomplete. Stupid. There we go. 20, there we go. Because we are computing the sum from 20 to 50, although that's actually not what the problem says. It says between 20 and 50. Let's do this implementation, and then I'll show you some alternate implementations. While x is less than or equal to 50, we want to compute a sum. So, hopefully everybody remembers what we were doing yesterday with adding time deltas to an elapsed time variable. That was also a summing operation. So, to compute a sum, you must have a variable other than the indexing variable, sum, initialized to, what should we initialize this to? Someone other than you? Sorry, say it a little louder.
50?
50? No. Because if we initialize the sum to 50, that means before we even start counting, there's already 50 in there. What should it be initialized to?
20.
Not 20, not 2. Not 30. That's it. 0. Because this is the starting amount, right? The starting amount should be 0, otherwise you have all of this magnitude coming from nowhere and not related to the sum you're supposed to be calculating. So, sum plus equals x. Written as it is right here, this is an infinite loop. X is not being modified. So if we were to run this right now, on the first iteration, x would be 20. We add 20 to sum, so sum is now 20. Then we go back up to the top. X is still, 20 is still less than or equal to 50. Sum gets 20 again, so it's 40. That continues forever, because we can reasonably expect that 20 will always be less than or equal to 50, because numbers, right? So, in order for the loop to actually terminate at some point, we must modify it inside of the loop. The typical way of doing this is x plus plus. However, the problem states that we want the sum of all even numbers. So there are two ways of, more than two, but there are two ways I'm thinking about to do this. One is the one that you said. Rather than adding 1 here, we say x is equal to x plus 2. So that way, we are counting 20, 22, 24, 26, 28. This is the efficient way to do it. A less efficient, but still correct way to do it would be as follows. Add 1 here, but only add it to the sum if x is even. If the if statement only contains one line, you can do something like that. For beginners though, probably just include the curly braces. Like that. So, this approach has the loop only hit the numbers that are relevant to the sum. This approach is more of a filtering approach. We generate all of the possible numbers and pick out those numbers that are supposed to be in there, right? This one is more efficient because it only has to process half the number of loop iterations. This one is less, it also contains less code. It doesn't have the if statement in it. This one is less efficient, but for certain types of programming applications, it's good to think in filters, right? Like it's good, like that's a good way of thinking about the problem, even if in this particular instance, it's not going to end up being the most efficient implementation. Once again, I am not expecting efficiency from you folks. I am expecting results. All I care about is that your code works. I don't care about, like basically, use this, use that, I don't care. Whichever one makes more sense to your brain, use that one. Okay? So, that being said, let me talk about that other thing that I was talking about. The way that this problem is written implies that we're running from 20 to 50 because of the positions of 20 and 50 in the sentence. But from a mathematical standpoint, all we're talking about is between two numbers. That does not imply an ordering. So, it is as valid to start at 50 and count down as it is to start at 20 and count up. For example, if I take this first implementation, start at 50, and while x is greater than or equal to 20, x minus equals x minus 2 rather than plus 2, that is the same thing. Those are synonyms. The memory is doing something different, but from the perspective of the final sum, they're the same. Does that make sense? Are you sufficient? Are you sufficiently satisfied with me just saying it, or do you want me to prove it? Yeah, there we go. Right. Did I start that recording?
I think so. Is it red circle at the top? It looks like
Yes. Okay, good. I always, like, the reason I turn this way in case, like, the battery runs out or I run out of memory or something. All right. So, it's going to complain at me because you can't reinitialize variables in C# like this. Doesn't make any sense. So I'm just going to remove the reinitializations. There we go. And I will add console.writeLine sum here, here, and here. Save. Get rid of this line here. Save. Run. There you go. The answer is the same all 3 times. Does this make sense? Hopefully. Okay. Now, you folks are going to get a chance to try. Question 2. The factorial of a number is the product of all numbers, all natural numbers less than or equal to the original number excluding 0. X factorial is equal to, here's another definition for you, x times x minus 1 factorial for x greater than 2 and x for x equals 1, greater than or equal to 2. Okay. Compute the factorial of the variable n. You will need to, of course, create n in your program. I'm sorry, you're on this. I hate wide prep classrooms like this for this reason. You know, if you need to read it, you go. Get to it. Write me this program. Yes.
What, do you want us to like type in variable n? Do you want us to make it up ourselves?
Instantiate the variable. Give it a hard-coded value for now. Yeah. Also, this is just kind of a math fact, because this is a real thing, right? Math fact, factorial of 0 is equal to 1. You can put that in too if you want, but yeah. Using exclamation point here is not allowed. That's the symbol in mathematics, but there's no symbol for it in programming. Yeah. And no library functions, folks. I don't know, does math have a factorial function? Maybe.
I was trying to think of that. I don't remember.
How rude of me to leave this console open. There we go. the algorithm that I'm concerned about. But if you write into your program 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, I will say, no, that's not an algorithm. Yeah. So I guess the thing you're computing, right? Factorial of 8 is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Definition of factorial.
So, if we were given like 20 minutes, do you have an idea of how to get it, but there's a good chance not gonna get it? Good understanding where we're at?
So I hope that everybody should be able to complete this exercise in like 15 minutes. Yeah,
So I need
yeah. This is a conservative extension of the program that we just wrote. You can do it. Just try something. You're never going to learn unless you play with it. Yeah, we're going to cover how to do that like next. But that also works. Oh. Yeah. That's a good start. Yes. So first, this is not programming, right? That's the mathematical operator. That's the definition of this function mathematically, right? So this line here is not C#, right? Also, I don't know why you have two operators here. You can't set ranges. You can only set single individual values. Also, these curly braces are misplaced. That is the assignment equal sign. You probably mean a comparison operator. Oh, remove that semicolon. See if that improves things. So when you get a bunch of errors like this, try doing the top one first. So x is a variable, but it's supposed to be. Oh, that's a malformed expression, right? You can't just say x times y. You have to say x times y is assigned to some memory. So perhaps you meant x equals x times y. This equals sign is not a valid operator inside of the condition. Did you get it working? Look at the math. Problems on that line.
Oh.
Did you get it? You are computing the square. You keep a running product in the same way that you keep a running sum. In that example, we keep a running product in this case. Yep. Getting a number is good. Let's see. So you are. There are elements in there that are correct. Line 23 is a good line. I like line 23. 24 is certainly an issue. Because like over there where I've got like 8 times 7 times 6 times 5 times 4, right? Here, you're saying n is equal to n times n plus 1. So what your next number in the sequence is 8 times 9, right? But the next number in the sequence is 7 in that case. Well, then you've got 8 times 7 as the next number in the sequence, which is actually, 56, which is going to be larger. Well, if you were calculating 8. In the case of 30, you're actually doing 30 times 29, and that's your next number in the sequence. Your next number in the sequence actually doesn't. Right? It's just strictly decreasing by 1 each time. Now, factorial of 30 is probably going to be a larger number. Yeah, you just hit buffer over. You just hit an interesting exception called the integer overflow. So the number that you calculated is so large, it doesn't fit inside of an integer. That's why it looks negative. But if you were to try something like, I'd say 5. There you go. Now, here's the other thing though. This is not a good stopping condition. Right? Like if, okay, let me show you on the board. Let's imagine a number line, right? Let's say this is 30, right? And n is 10, right? If we go into this zone, the loop turns off, according to your algorithm, right? Because you've got greater than or equal to 30. No, you have less than or equal to 30. So, for you, if n is in this zone, it turns off, right? So, what what you want is N2 decrease 9, 8, 7, 6, 5, 0. You want that to be your limit. Once it hits 0, it stops. Or actually, 0 multiplied by everything would result in 0. So you want to stop that. That's when you want to stop. Because you're doing an implementation where you start at N and you go down. Yeah. Again, you can do one where you start at 1 and go up. But because this is how you've chosen to do things, you have to think about like where your barrier is. Does that make sense?
Yeah.
Cool. Math. Math is cool. Math is fun. Math is fun. All right. As if I would lie to that lady about what the policy is. Was I nice? I was trying to be nice.
The funny part when she was asking like specific days, like, was it on Mondays and Fridays only, or you just like, I look here and it's just the same thing every day?
I mean, I have every class except for on Thursday this semester actually, but you know. Many have been the semester where yes, I have taught a class every single day of the week, and yes, that is the policy no matter what day of the week it is. Goodness gracious me. It's an interesting little form of particularism though.
Yeah.
You know? It's like, oh, is that for just now? It's like, no.
That'd be weird and specific.
That is, yeah, like, yeah, no, the college has a policy which applies specifically to the middle of Wednesday afternoon, you know? I'm just griping because she ate up like 5 minutes of me being able to nerd out about math time. But like, actually, like, that is an unkind thing to do to students because like, you may have noticed, they don't always give you a gap between your classes. Like, you can have a class in this classroom and then have to book it to A wing, you know, in 10 minutes, which you can make that. That's actually why in this particular time slot I'm going to be consistently later, is because I'm actually coming from the from H wing like immediately before, so yeah. But like at some point that's a failure on the part of the institution to make these policies known. I presume she's a part-timer, you know, so. It's possible that it's like a continuing education class. They, because she said it was starting this week, right?
Yeah.
So that's actually fairly common with CE courses, is that they start a few weeks into the semester and like only go for like 6 weeks or something like that, you know. But anyway, how many people got something? How many people got it working? 2. How many people are close to getting it working? But you said you got it working. You can't get close to getting it working and have it working.
Yeah, there's the one where
How many people have no idea what they're doing whatsoever? Well, it's good to admit it. So, let's walk through this one carefully in the next 10 minutes. So, similarly to the last one, here we need one variable to keep track of where we are in the sequence, and one variable to accumulate the output. So if we take a look at any example of a factorial, take for example 4. Factorial of 4 is equal to 4 times 3 times 2 times 1. That's what we're trying to compute. So we are trying to generate each of these numbers in some sequence. We can start at the top and go to the bottom. We can start at the bottom and go to the top. Who wants to start at the top? Who wants to start at the bottom? The tops have it. So, if we are starting at the top, what is the top? N. That's right. So, let's say I'm just going to pick a value of 8. I'm going to use more variables than is necessary so that it makes more sense. So int top, or int index, that's what this is called. This is called an index, is equal to n. Now we have to keep an accumulating variable. In the case of the summation, the first problem, this was called sum. Here we are computing the product, not the sum. So we choose a variable name that makes sense. Personally, I would choose product. Now, this is an interesting little problem. In the case of a sum, we use 0 because anything added to 0 is the number that you put in. What number has that same property with multiplication? So 1 is the number you want to start off with when computing a product. Sound good? Now, we are computing, now we write our loop. While now remember, we are going from the top to the bottom. What number are we starting at? N. Right? If we're starting at the top, we're starting at n, so index is equal to n. When do we always stop? When have we finished generating this sequence of numbers? When you get to 1. Exactly. So, while index is greater than 1, do the thing. As soon as it is 1, stop doing the thing. Sound good? Making sense so far? Hopefully. Any questions? Okay. Now comes the fun part. Getting from one number to the next. What is the difference between these two numbers? What operation do we perform to get from here to here? Yes?
-1.
We subtract 1. Do we do that every time?
Yes.
So, we subtract 1 every time. Index is equal to index minus 1. That will be the last line of your loop. I did that first because without that, it's an infinite loop. Number 2, how do we compute the product?
Product equals product times index.
Yes. Product is equal to product times index. And that is actually sufficient. Console.writeLine, writeLine, factorial of n is equal to product. I didn't ask you for a fancy print statement like this, but, you know, since we're here. Execute. Factorial of 8 is 40,320. So, not being satisfied, let us perform a program trace, but let's do it with a smaller number. Does anybody still need this? Nope? Okay. Alright. Program trace. Here is our program table. Whenever you don't understand how a program is working, this is what you should do. Alright? Unfortunately, I do need some whiteboard for this, so if you two want to come over to this side, I'll, you know, that. If not, you know, whatever, but if you want to see what's going on, then I recommend it. So, we have our number n. Let's pick a smaller number for this, let's say 5. 5. We declare index as, what are we assigning to it? The value of?
5.
Yes.
And
Well, we're assigning it n. N has the value of 5. So we take this and we copy it here. Good. So far, so good. Product. Initializing with a value of 1. Very good. That's all we need. Now, is index greater than 1? Yes. So we execute the loop. Product is equal to product times index. Product is equal to product times index. What is that? 5, good. Next, index is equal to index minus 1, so 4. Very good. Back up to the top, retest the loop condition. Is index greater than 1? Yes. So we iterate the loop one more time. Product is equal to product times index. Product is 5, index is 4. 5 times 4 is 20. What's next? Index minus 1. What does that write into index? 3. Good. Back up to the top. Is 3 greater than 1? Yes. So we iterate the loop. Product is equal to product times index. What is product? What is index? What is product times index? Very good. Index is equal to index minus 1. What is index? What is index minus 1? Yes, sorry. Index is 3, index minus 1 is 2. That's not it. So index is not 2 until you compute index minus 1, right? Like, don't skip steps. This is like, the reason I'm pulling you guys through this painful process is I am trying to train your brains to think like computers, all right? The computer does not skip steps. They do not abbreviate steps. They go through everything painfully and procedurally. Right? If we are to program computers, we must think like computers, which means we must think painfully. All right? So, that's 2. Is 2 greater than 1? Yes. So we iterate the loop one more time. Product is equal to product times index. What is product? What is index? What is product times index? 120. What is so what operation are we performing on index? Index minus 1. What is index? What is index minus 1? Write that into memory. Is 1 greater than 1? So? We stop the loop. What do we do next?
Print out the.
That's right, we execute the print statement. And that concludes the algorithm. And that concludes the class. So, thank you very much. Y'all need practice. Go practice loops. I shall post the code. See you Friday. Oh, quick before everybody leaves, I see nobody's in a hurry. Lab 1 on Friday, be on time. We will be working on it in class. Your reflections will be due afterwards, but I am hoping that you will be able to perform the work itself inside of class time. Okay? I will post Lab 1 sometime tomorrow, I think. Okay. That's it. Thank you. Yes?